Find the sum of the infinite series 1 plus 1 over 4 plus 1 times 4 over 4 times 8 plus 1 times 4 times 7 over 4 times 8 times 12 plus 1 times 4 times 7 times 10 over 4 times 8 times 12 times 16 and so on. So this one looks like this is an infinite series, but this one looks like an expansion that is going till infinity. Right, so one of our theorems that we used before could be useful. So let's take a look at the expansion of 1 minus x raised to the power a fraction, which is minus a over b. So if you closely compare the right hand side of the equation here, it actually resembles or can be simplified in this form here, right? So you have 1 plus some fraction here plus some fraction a times 1 times 4 over 2 times something plus so on. So if you carefully look at it, each of the numerator has 1 times 4 times 7, and here you have a times a plus b times a plus 2b. So it is incrementing, right? So if you compare the fourth term in both sides, which is 1, 2, 3, 4, so this part and this part here, what is increment here? 1, 4, 7, right? 1, 4, 7 is 1 times 4 is 1 plus 3 times 7 is 1 plus 2 times 3, right? 2 times 3. And here you have a times a plus b times a plus 2b. So very clearly b is equal to 3 here, right? And how about a? A is 1. So we got a and b. Let's see if that is true. So here if a is 1, okay, b is 3. So b should be in the denominator. But doesn't look like it. But let's see if we can do something else to that. So here in this question here, ax over b, right? Ax over b should be 1 over 4. And if a is 1, b is 3, you get x over 3 is equal to 1 over 4. So what is x? X should be equal to 3 over 4 if you cross multiply. So let's see if this is true. If you substitute a equal to 1, b equal to 3, and x equal to 3 over 4, let's see if we can simplify this equation here to here. So this would be 1 plus a is 1, so you get 1 times x is 3 over 4 times 1 over b is 1 over 3, okay, plus a is 1 times a plus b is 1 plus 3, 4 over 2 factor, which is 2, times x is again 3 by 4 whole square times 1 over b square, that is 1 over b square is 3 square, plus the next one would be a times a is 1, a plus b is 4, a plus 2b is a plus b is 3 times 2 is 6, 7 over 3 factor, which is 3 times 2, times x cubed is 3 over 4 whole cubed, times 1 by b cubed, which is 1 by b is 3 cubed, and so on. So let's see what this is. 1 plus, so 3 cancels off and you get 1. So let's take a different color, which will be much easier. So this is 1 plus 1 over 4 plus your 3 square cancels off, but in the denominator you get 4 square, which is 4 times 4, right? So you get 1 times 4 over, so you have 2 4s, you can write 1 4 here, times the other 4 times 2 is 8, plus here you get 1 times 4 times 7, So 3 cubed cancels with the 3 cubed here. So you're left with 4 cubed, right? So you have 4 times 4 times 4. So you can write the first one 4 times, the second 4 times 2 is 8, and the third 4 times 3 is 12, right? Plus the next one you will have 1 times 4 times 7 times 10 over, if you do the same thing here, you should get 4 times 8 times 12 times 16 plus so on. So this is exactly same as this power series here. So these values are in fact correct. A is 1, B is equal to 3, and X equal to 3 by 4. So what is the expansion here? This expansion here is nothing but 1 minus X raised to the power minus A over B. So let's substitute these values back in here. So if you substitute X as 3 by 4, you get 1 minus 3 by 4 whole raised to the power minus A over B, which is minus A is 1, B is 3. So what is 1 minus 3 by 4? That is 1 by 4. So this is 1 by 4 raised to the power minus 1 by 3. So if you have minus, 1 by 4 becomes 4. So 4 raised to the power 1 over 3. So the expansion of 1 plus 1 over 4 times 1 times 4 over 4 times 8 plus so on is equal to cube root of 4. So whenever you have this kind of series, the first thing is to find what is A and what is B, right? And then find the X by using the second term, and then go from there. It will be much easier for you.